Okay, so we're starting at point A from rest. So at point A, what type of energy do we have? All potential. At point B, what do we have? Kinetic, potential, or both? Only kinetic. Good. So at B, we would set up 0 kinetic plus mgh equals 1/2 mv squared plus 0. Okay, let's say that our roller coaster for ease has a mass of 100 kilograms. Okay, so our roller coaster has a mass of 100 kilograms. At point A, we've got all potential, which on this side is the before, that's point A. This side is after, which is point B. Okay, so we'd say 100 times 9.8 times the height. Okay, we said our cart has a mass of 100 kilograms. Okay, agreed so far? Okay, that was pretty simple, right? All potential to all kinetic. So now if we want to go to point C, do we need to go, there's a couple ways we could do this. We could go from B to C, or we could always just go from point A to C. Since we know the amount of energy is going to stay the same from the beginning to the very end, you could always start at point A and go to whatever point you want, or you can start where you left off and go to your next point. Okay, is there one way that you would prefer to do that? From A to C? Okay, so from A, right, it's going to be only potential energy again. So we can just use this exact term, right? At A, we know it only has potential energy, so we can just use this number. Okay, we know it has 39,200 joules worth of energy in that roller coaster. That's how much energy is in there. So we know, since we're going from A to C, we know we're going to have no kinetic plus the potential energy, which was 39,200 joules worth of potential energy, right? You can still plug in mgh here again. You're going to get the same number since it's the same scenario. At part C, what type of energy does it have? Both. It has both. Okay, so kinetic would be 1/2 times 100 times v squared. We're solving for the velocity, plus m times g times the height at point C, which is 30 meters. Okay, we're going to combine like terms and subtract over that 29,400. Do we agree there? We did a problem kind of similar to this in our original notes. Okay. Now we're going to look at point D. Okay, so do you want to try that one on your own? Okay, you can either go from point C to point D, or you can go from A to D, okay, because the total amount of energy will not change. So I'm going to go from A to D again. So I just want to make one little clarification here. If you wanted to go from point B to point C and then C to D, that's fine. You're going to use some more terms. So let's just, you don't have to write this part down. I'm just going to show it real quickly. If I wanted to go from point B to point C, okay, what type of energy do I have at point B? I have all kinetic. So I would say at point B, I have 1/2 times 100 times v squared, and I know the velocity at point B is 28. So I'm going to use what I found in the previous part. Okay, it has no potential energy. At point C, we know it has both, so I'd say 1/2 mv squared. Sorry, we know our mass here. 1/2 m times v squared plus 100 times 9.8 times 30. Okay, when I solve this right here, 0.5 times 100 times 28 squared, I get 39,200 joules. Okay, isn't that exactly the same amount of energy that we proved to be in part A? Right, that's the whole point, that energy is conserved. So I'd take 50 v squared plus and I'd subtract that over, and I would get the exact same thing that I did when I solved it the other way. So you can use either one. One of them kind of builds upon themselves. One of them starts from the beginning each time and works its way down. Okay, that's probably a type of question that you should be familiar with for the test.